will be seeing about rectifiers, which is a basic so this rectifier is a device that is used to convert alternating current into a direct current by using non-linear P junction diodes. So this alternating current is converted into a passive current by the use of a diode where by the use of P junction diode where the junction where the diode is used for bias and it does not conduct into series bias. Due to this property, the diode either gives a pure DC or alternating DC at the output for a given input signal. So this is an automatic signal that is given to a rectifier circuit which gives a direct current. Here the rectifier circuit that we have taken is considered to be a P junction diode and positive offset an input signal is given for as input for this diode. I am getting a direct current which is a pure DC. On the other side, you can also give a pulsating DC. Rectifiers are of different types based on how the output is processed. It is the half-wave rectifier and the full-wave rectifier. Full-wave rectifier is further classified into center-tape full-wave rectifier and a bridge rectifier. For a half-wave rectifier, we are using a transformer and a diode. So this transformer consists of two windings, which is the primary winding and the secondary winding, along with a diode A and a load resistance R. For this half-wave rectifier, we are given alternating AC input signal. So this AC input signal is given as input to this diode. So whenever I have a positive half of, whenever I have this positive half of my input signal that is given as input, that positive signal and this positive terminal of my diode gets combined and makes this diode to be forward bias. So the signal comes out as the output. When I have a negative input signal that is getting into this transformer, that negative signal and this positive makes this diode to work in reverse bias. As we all know that the diode does not conduct in reverse bias conditions, I will not have any output appearing on the other side. So alternatively, for the positive half cycle, I will be getting an output. For the negative half cycle input signal, I will not get any output. This is a simple explanation of the half-wave rectifier. Now coming to see how this rectifier works is, this is the place where I'll be having my diode. This diode works only for the positive half cycle. That is only when the diode is forward biased. When the diode is forward biased, we call that to be closed switch, and when the diode is working in reverse bias, we call that to be open switch. Here is a positive half cycle of my input signal. For the positive half cycle of my input signal, I am giving my input this positive and the positive terminal of the diode makes this to work in the forward bias, so it acts as a closed switch. So the signal that I'm transmitting here moves to the other end and I get my output. But when I have the negative half cycle of my input signal, this makes my diode to work in reverse bias, so it becomes an open switch. In that case, I will not have any signal that is moving from this terminal to the other terminal, so I will not get any output. So when I have an alternating current which is given as input signal, for the positive half cycle I will be getting an output, for the negative half cycle I will not be getting any output. So this makes my half-wave rectifier to get a pulsating DC output. In a half-wave rectifier, if you see, this portion of the signal is being utilized, but this portion of the signal of the power that is being used to process the signal rectifier circuit is getting completely wasted. So in order to use that effectively, we are moving for full wave rectifiers. So the full wave rectifier consists of a transformer along with two diodes. In a half wave rectifier, we were using only one diode. Here we'll be using two diodes where for one portion of my input signal, my diode D1 will conduct, for the other portion, my diode D2 will conduct. The diode which is not conducting moves to the reverse bias condition. So at the output, I will be getting the positive input of the output for the positive cycle and the output for the negative cycle of my input signal, and finally these two the outputs that I want will get combined and I'll be getting the output for which the entire input signal has two diodes, I am giving a positive half of my input signal for this transformer. When the positive cycle of the input is entering into this diode D1 will be in forward bias and diode D2 will go to reverse bias. In that condition, what happens? I will have only the positive signal which is getting at the output. When I go to the negative half cycle of my reverse input signal, this diode D1 will go to reverse bias and D2 will be in forward bias. So I will I will be getting my positive cycle. I will be getting my negative cycle at the output. So when I combine these two outputs, my positive half cycle as well as the negative half cycle is getting combined and I'm getting as so this is the output comparison graph of the flow wave rectifier using a center tape transformer. This is the input signal that I'm giving. This is the output for one of the diode. This is the output for the other diode, and this is the combined output of a center tape transformer. So this center tape transformer full wave rectifier uses the center tape transformer where the circuit becomes complex and failure. Due to that disadvantage of complexity, we are moving to another type of full wave rectifier, which is a bridge rectifier. In a bridge rectifier circuit, we are using 4 diodes instead of 2 diodes. So in this condition, for a given input signal, 2 diodes will be forward condition and the remaining 2 will be in the reverse bias. For the next half cycle of my input signal, the diodes which were in the reverse bias and forward bias will get inverted and start. So this is the during the positive half cycle of my input signal. Here this bridge wave rectifier can also be used along with the center tape transformer. So here I am giving the positive half cycle as input signal. When the positive half cycle is given as input signal, my diode D1 and D2 will be in the forward bias. Diode D3 and D4 will go to reverse bias. So as we have seen in the previous slide, diode D3 and D4 when it is reverse bias, the diodes will not affect. So the given input signal will take this path, that is, it will come through the transformer, it will reach the diode D1, come to RL, then D2, and again it will start moving within the circuit. This is how the signal flows when I have a positive half cycle which is given as input. Next, I am giving the negative half cycle as input. This negative half cycle is given as input. Diode D1 and D2 will go to reverse bias. Diode D3 and D4 will be in forward bias. So the signal will take up this path D3, RL, D4. That's all. This is the path for the signal to travel when it is reverse bias. That is for the negative half cycle. So for a bridge wave rectifier also, I will be getting the same output. With the positive half cycle, I will be getting one signal. For the negative half cycle, I will be getting another signal. So here is a comparison table of my full wave rectifier output. Here is the AC input for both my bridge rectifier and the full wave rectifier with center tape transformer. Here I have my output for the positive half cycle. This is the output of the negative half cycle, and here is the combined output. So when we see a half wave rectifier, it is simple, but then most of the power is getting wasted. For a full wave rectifier with center tape transformer, the power is being used efficiently, but then due to the use of transformers, the circuit becomes heavier. But when we have a full wave rectifier with 4 diodes, that is a bridge circuit, we have the circuit is simpler and also the power is being used